Hey guys, welcome back to the channel. Have another Marine ECM computer test, this time working on MEFI 1. I have to actually look into that. Yeah, MEFI 1 coming from North Carolina. Robert, let me just see, Robert Hooden from Motorboard Mechanics. I'm checking your computer. So far it's running good. I was able to establish communication. As you see, when I started the video, I lost the communication for a brief second. I got the fiber reference steady, fuel pump driver is going. Um, the values are correct as far as temperature, because that's one of his concerns. There's no communication. Temperatures are all negative degrees with no set warnings or horn. I have one fault code right now. It was nothing in there. I have actually pictures of that. So right now I'm running in idle. Let me see what fault codes we have here. Yes, this has a constant knock. Well, that's normal because I don't have the knock module connected. Let me raise the RPMs to like 3,000. Let me just keep you here for 1 second. And let me adjust the throttle position accordingly around 40%. I don't like to change much of the auto values, even though right now the map is a little high to what I'm used to having. I'm always in like around 12.6 or so. Raising the idle a little bit is not abnormal. Obviously, the manifold pressure will raise up, but we see a steady injection. The module is running good. I don't see any problems on that. No checksum errors. The boat has, let me actually get a zoom on the RPM, throttle position, IAC position, that one. That's the base. Okay, IAC position. Let's see what else I want. Then this is a spark advance. I can only select 4. Oh, looks like I already have it. So that's spark advance. I didn't have select the throttle. All right, so we got the throttle. We can see that from the distance, and this has 491.55 hours. So far running 4.77 minutes, and the minutes are adding correctly. So this is in tens, not in like the normal 60, 60 seconds per minute. This is in tens. So it's a 10 per hour, meaning the same thing, right? All right, so let me lower the RPM to idle again. Too much. And lower the throttle around 7%. That's what I like to keep it at idle. Battery voltage steady. Injection is steady. We can see that. I'm going to lower now the throttle. I mean the map value, which I don't have selected because I want you to see the changes on the IAC position, which are happening. The changes on the spark advance are happening. Disregard this is just this multimeter draws so much power. I haven't used it since the last test in like a couple of weeks or so, and the battery is already dead. So I'm gonna have to put it to charge. But the fiber reference is steady. This computer uses 2 fiber reference. So let's check the other one up. The one I have right now is for the TPS. So I got those selected separately so we can check, or I can check both. The other one is on the map, and we can see the sensor ground and the fiber reference. Both are good because these are sensor grounds and power, fiber reference, and the same things in here. So nothing in there is bad. I'm going to stop the running. We can see that we have now 0 engine RPM. I'm going to turn this off, so we're going to lose communication. We're going to see that on like in there. I'm going to turn it back on. We can see the fuel pump prime. Now it reconnect automatically, so not a problem in connecting back to Diacom, but I'm going to disconnect and then reconnect Yeah, everything is happening instantly, not a problem. I'm going to select like a new computer, like everything is off. So I'm going to turn this off one more time, turn this back on. We can see the fuel pump prime working properly. All right, so I'm going to select, this is Diacom Marine Rinda. I select MEFI 1 to 4. This is a MEFI, I think it's a MEFI 1. Connections are the same on those. It's a 5.7 Indmar. All right, so I'm going to connect in here. This is going to, I'll go obviously with ignition on. For diagnostics, I select always mode 1 and then connect to the computer. And it's happening, not a problem every single time. The calibration checksum on this one is 9D7D. I don't have the calibration files for Indmar, but usually when something like that is run, it will give you checksum error, and that's not happening. So, all right, so let's run it again. 45 hertz on this setup that I give, that will be idle, and it's running. As you can see, we have the injection milliseconds and everything in there, so the computer is running every single time. Robert, I'm gonna keep it off the video. I have run the computer for not too long, let's say, 10 minutes, 10, 15 minutes. I'm gonna run it for an hour on the simulator, let it warm up, let it see if something happens when the computer warms up. Your notes are very specific, no communications and temperature, all negative. I want to show you, well, since I didn't do that because I selected all repeats for the start of the test, that ECT and coolant and air temperature are reading properly. And I can change those in here, right? So I can change the coolant temperature. I can go up and down, and you can see that it's like, since this is a complete control environment, I can change that, and I can do the same thing on the air temperature. So we can go lower and higher, but it's staying on a normal range. Nothing goes negative. Usually when you have negative values on thermistors, right, temperature sensors and coolant temperature sensor, that led me to believe that you're losing a ground. The computer usually sends, and that is very specific on thermistors, right? Thermistors are usually either a one wire and they get the ground through the block on the boat, or the computer has a separate, it can be also two wires, so where the computer will have the signal coming on the one wire, and then it provides the ground for the sensor, so it's not counting on the ground on the block. But very specific on the thermistor, let's say if you have a one wire thermistor sensor for the manifold air temperature or for the coolant temperature, right? If it's a one wire, that wire is not just a 5-volt reference, let's say, it's also the signal. So that is a very different than the 5-volt reference for the total position sensor or the MAP air pressure sensor, right? When you have a 3-wire pressure sensor or a throttle position sensor, you will have a sensor ground, a 5-volt reference, and the signal, right? So those are the 3 wires. So the signal is very specific because the sensor itself will change. Let's say, like if you're working on a throttle position sensor, depends on the throttle position, the resistance internally in the sensor will change, and the voltage that goes out on the signal will go from, let's say, 0.5 volts to 4.5 volts, and that is the signal. On the thermistors, completely different. The computer sends the 5 volts, but it's also the signal because it's meant to be pulled down to ground. So that is the only one, because if you're trying to pull down on the throttle position sensor that 5-volt reference to ground, you will short the computer, you will shut off the boat because it's not meant to be pulled down to ground, right? That is just a voltage. The sensor will produce a signal, and the signal is protected, the signal. But the 5-volt reference is very, very delicate. If the 5-volt reference gets shorted to ground or shorted to power, which is the worst, short to ground, it will shut the computer down. Short to power, it will cook the computer. All right, coming back to the thermistors, which is the explanation that I want to give. On the thermistors, that signal, which looks like a 5-volt reference when there's no ground, or if you disconnect the sensor, it will read like 5 volts. But you can touch that wire only on thermistors. I want to be very specific with that. If you touch that sensor to ground, that signal, you put it right to the block, it would show minus 41 degrees or the opposite. Depends on the manufacturer design, right? Some sensors, when it's open, it will read minus 32 degrees or 32 degrees, depends on whatever the calibration, the maps on the values for the sensors are set from factory. So the minimum temperature can be 32 or minus 40, depends on the manufacturer, right? But if the sensor is disconnected, some manufacturers will put that as a minus, so you know when you're reading minus or negative values on temperature, it's most likely that the sensor has lost its ground or the sensor is open, right? But if you have both temperature sensors, manifold air temperature and coolant temperature reading the same, and they're just a one wire sensor, I will immediately check the block grounds, clean them, because that is the number one failure on these harnesses, on these boats, right? Corrosion, harnesses corroded, and then loses of ground, which at the end will cook the computer too, because injectors are using the computer as part of the circuitry, right? The drivers are inside, and then the computer is providing the ground for those injectors through the driver. So if the grounds on the block are dirty, it will try to use the grounds on the computer, and it will cook the computer. All right, guys, I hope that this is also a good explanation for any of the techs that are looking at these videos. If you have any marine computers and you want to send over for testing, you are in the best hands. I am completely transparent. I show my testing 100%. I have all wire diagrams, all harnesses made by me, and I try to stress the computer to help you out get the correct answer or guide you to what do you need to check on the boat. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.